Hi trolls, this is Mr. Lim here again, and this is the last video for organic chemistry. Okay, so we're going to be learning about how to identify some of the organic substances using their physical and chemical characteristics like we did before. But now we're doing them with a few more amines, amides, esters, and amino acids. Alright, so again, following properties are general, same ones that we had last time, but it's added a few more. So ability to be oxidized, acidic or basic nature. This one also can be reduced as well, because carboxylic acids and therefore amino acids can be reduced. And so therefore that's something else we'll talk about. And then acidic or basic nature, the smell for esters, and then melting in point and solubility if you really have to. Okay, so the ability to be oxidized, again, you're reacting with a strong oxidizing agent and preferably a self-indicator such as potassium permanganate or sodium dichromate, and don't forget to write down acidified. Okay, this applies for amines and amino acids because they both have an amine group on them. So amines turns to amides. You can watch that reaction on the amines video. And amino acids, the amine group can be oxidized to the amide group. So that's again on the amine video. Again, you need to really make sure that you are using the self-indicating oxidizing agents, which is useful. All right, and then you should know their color changes. For the permanganate, it's purple to colorless. For the dichromate, it's orange to green. Okay, and then you should always be saying in your answers what you need to do. You need to add a limited amount of it so that you can see the color change. Okay, so these are the differences between your B and your A grade students. When you say, okay, I add a acidified potassium permanganate, no, you need to say I need to add a limited amount or a small amount of potassium permanganate, acidified potassium permanganate, just so that you can definitely see the color change. That's that extra 1 mark to get you to the top, right? Then we have acidic basic nature. You can place an indicator in there or use a pH meter. Amines and amides. Amines are basic, amides are acidic, which is unusual, but that's just the way it is. All right, and then some amino acids are acidic or basic depending on their R group. Again, using the pH is technically not a chemical property. You could argue that using an indicator is a chemical property because you're having a chemical reaction occur with the indicator itself. However, you can do other reactions such as adding a carbonate in there and the acid will react with that and form carbon dioxide, which is a chemical reaction. But generally, you can say, I'll put an indicator in and see if it's acidic or basic. Just really read, it depends on what the question is asking for. Right? If it's asking for a chemical reaction, then you'll have to show the indicator reaction, or if it's asking for a reaction, then maybe you might choose to use a carbonate to show that acid reaction. All right. And then finally, smells. Okay, so carboxylic acids can smell like vinegar and esters have a fruity smell. Generally, all organics can be described as pungent because they have a strong smell, but they all smell different, and so that's not very useful until you get to the esters and the carboxylic acids where we have words to define those smells. All right. And then generally, we also have amino acids which have a significantly higher melting and boiling point. So if you can't tell an amino acid from all the others, then you can just purify it and then melt it if you really have to. Okay, so this is the big table of all of the substances, and you'll notice that with these three characteristics, all right, we can pretty much separate and identify all of them, except for the primary and secondary alcohols. They are the only ones that share those two characteristics. Also esters and ketones, and so therefore that's why we need to have that pungent versus fruity smell. And then amino acids, if you're unlucky to get a couple of amino acids with a funny R group, then you're screwed, but generally you're not going to get those kinds of questions. It's going to be fairly easy to differentiate using either the reduction or the oxidation reactions or the acidic basic nature. All right, so that's it. All right, if you have any questions, come and ask. There'll be a couple of videos on the WACE exam questions from the last couple of years to come out as well, just in case you want to watch and just in case you want to see the types of questions that you're going to get. All right, that's it.